So moving on to the third advanced technique, so we have the integration by parts. And as you can see in the formula, so this one is on the left side, that will be the format that you will be achieving on the left side. And then the particular integral or the answer for the integral on the left side will be this one, the right side. So uv minus v du. So meaning you upon achieving the answer, so the uv minus v du, so you still have to integrate again the integral of v du. So for this formula, so if you know well the product rule or the chain rule of your derivatives, so let's go back. So let's say you have the uv, then getting the derivative, so you have, so that's u dv plus v du, diba? So if you want to go back to the original answer, so we need to integrate u dv plus v du, diba? So muna siya atong button sa if you want to go back to uv na answer. So upon integration, so we need to integrate this whole thing. So we'll be having uv is equal to integral of u dv plus the integral of v du. So if we try to isolate one integral, so that leads us to the integral of u dv, and then we'll be having uv minus the integral of v du. So that's where the formula came from. So it came from the product rule or the chain rule of your derivatives. Okay, so what's the purpose of using integration by parts? So as we go to the second portion here, so the purpose of determining your, using your integration by parts is you have products of different functions. So for example, algebra against trigo. So one example of this, for example, is x squared times sine x, diba? So these two are different functions. So for example, you also have trigo plus exponential functions. So let's say e to the power of 2x cosine 2x. So the two functions are different, diba? So for example, you also have algebraic and exponential. So it could also be, so let's say x squared raised to the power of x, diba? So these two have different functions. So that's why we need an advanced technique, because since the two functions are of different of different types, so it's difficult for us to use basic functions or basic formulas to get the integral. So we need the integration by parts for us to dissect different functions respectively. So it also works for logarithms. So especially for logarithms, because for example, you are given the integral of ln of x dx. So notice that we don't have any formula for the integral of logarithms, but we have the integral of the derivative of the logarithm, which is du over u, diba? So we have this one, but we don't have the integral for logarithms. So in this technique, we can now integrate your logarithms, but again, it's not a formula, but since we'll be using this technique, so we can achieve a much simpler form of your logarithms. And lastly is your inverse trigonometric functions. So what do you mean by your inverse trigonometric functions is that you are given the arcsecond. So let's say the arcsecond, the arctangent, the arcsine. So again, as you notice, you don't have these formulas in your integrals, but of course the derivative of these inverse trigo functions, which is the format that I have presented to you last meeting, katong du over a squared plus u squared. So we have the integral for those one, which leads us to the inverse trigo functions. So if you're given the inverse trigo function, so we don't have the formula for that one. So we need to use integration by parts for us to solve the equation. Okay, so how do we use integration by parts? So let's go back to the first kanisha. So in choosing u and dv, so we need to choose u and dv because we are following this format here. So we need to assign u as equal to something, and then your dv be equal to something also. Okay, so the first step is, the first tip is dx is always included in dv. So let's have an example here on the upper right. So let's say x squared e to the power of 2x dx. So the first statement means that when you let dv be equal to something, so apel c dx. So dx is always included in dv. So let's say you're going to let e2x dx be your dv, and then your u parameter will be the x squared. So that's how you assign your u and your dv. So always remember that the dx is always included in the dv. So next step is that it must be possible to integrate dv directly. And it is best usually to choose the most complicated factor as dv. So in these two tips, so to sum it up, so you need to choose the most complicated factor or term, but the most complicated factor or term is possible to integrate. So that's how we can achieve your um, dv. Because notice, why do we need to integrate dv? Because we have a v on the answer here on the right side. Okay. So another tip is, since we need to choose the most complicated factor as your dv, and it should be possible to integrate, so you should also choose your u parameter. So this one. So wala na apil dire. So you need to choose your u parameter as an easy factor. So easy factor. So that's the opposite of your dv. And it can be, so it should be possible to derive. So possible to derive. So that's the opposite of your dv term. So if dv is possible to integrate, and it should be the most complicated factor, the u parameter should be an easy factor. So in most cases, it's not an easy factor, but it should be possible to derive or easy to derive. Possible or easy to derive. So why do we need to derive u? Because looking at the right side of the formula, we have your du here. Alright, so for you to appreciate the different um, concept of integration by parts, so let's solve examples. So dali na siya. So we have 9 examples. So basin makuratan mo nga, basin mula pas tag 12. So I think you only be up until quarter to 12 if it's possible. So upon observation of the 9 examples, so diba murag algebraic against exponential, algebraic against trigonometric, logarithmic, inverse trigonometric functions. But we also have complicated terms, trigonometric, and then logarithmic with a base of trigonometric. Then we also have purely trigonometric, exponential against trigonometric, algebraic against exponential, exponential against trigonometric. So that's how you determine if you're going to use the integration by parts. Okay, so in number one, so looking at your two terms, again, we have different functions. So let's try to apply first the technique. So again, as the technique says, states that we need to identify u and dv. So for you to write this one, so I suggest that you write it in this manner. So u here, and your dv is on the lower right, somewhere here. So there's a purpose why we write it in this manner. So next is again, we choose the complicated term as your dv, and it should be possible to integrate. So this will be, the complicated term is e to the power of 2x, because of course the x parameter is a simple term. So don't forget dx, as the definition states that we need to include dx in your dv. So this one is your dv. So the other term is your x variable. So next step is for us to determine the derivative and the integral. So integral of dv first. So I'm going to use another color, so v. So integral of e raised to 2x dx is 1 half e to the power of 2x. So why there's 1 half? Because we have a coefficient of 2 in the exponent. So again, the formula for this one, if you don't know, if it has an exponent, I mean a coefficient, so that will be a 1 over a e to the power of au plus c. Alright, so we have the v portion. So the plus c will be applied in the final answer na lang para kaisa mo mag-incorporate sa tanang c parameters. Okay, so next is we're going to have the derivative of u. So du. So notice that it's easy for us to get the derivative. We have dx. So again, what we have done so far is getting the u and the dv terms, and then next is getting the integral of dv, then getting the derivative of u. So again, let's write the formula here. So the integral of u dv is equivalent to uv minus the integral of v du. So following the format, so u times v first, so that will be x times 1 half of e raised to 2x minus the integral of v du. So that will be 1 half e raised to 2x dx. So simplifying further, so we have 1 half x e raised to 2x, then getting the constant outside, so we have e raised to 2x dx. So notice that the integral on the right side can be easily be integrated since we have the basic formula. So the final answer for this one is 1 half x times e raised to 2x. So 1 half times 1 half e raised to 2x plus c. So you're going to have 1 half x e raised to 2x minus 1/4 e raised to 2x plus c. So this is one possible answer for your final answer. So you can also represent it as in this manner. So you can factor out e to the power of 2x, and then you have 1/2 x minus 1/4 plus c. So it could also be in that manner also. Okay, so do you have questions or clarifications so far? So marag CCU pa ka siya, no? So actually, if you're going to think of it, so the problem can be solved by u sub lang, di ba? So let u be equal to 2x and then du dito siyang pididay. Habi ng x squared siya. So wrong day. So if it's x squared, so you can use the u sub there. Okay. So I think there's no question. So let's try to proceed with the next example. So we have x times secant squared x. So again, since you already know that we need to use integration by parts since we have algebraic times trigonometric function. So again, we set your u and your dv first. So again, write it in this manner. So we know how to determine the v and the du later. Para inline lang sila, di ba? So complicated term here is secant squared, obviously. Secant squared x dx. So can we integrate secant squared x? So of course we can integrate that one because we have a formula for your secant squared x. Then again, the simple term for you is x. So next is we try to integrate dv first. So getting the integral, so v is equal to, so integral of secant squared x is tangent x. And then du is equal to dx. So dali-dali rin siya ang kuhan. So I think it's easy to remember your integration by parts compared with the other advanced techniques. Okay, so writing the formula so we can be guided. U dv is equal to uv minus the integral of v du. So uv first. So you have x tangent x. So minus the integral of v du. So the integral of tangent x dx. So we have a formula for the integral of tangent x. So that will be x tangent x. So minus the ln. So unsa na siyang ln gani? So that will be secant, diba? Secant x. So secant x in the positive value of your integral tangent, but if you want a negative, so that will be negative ln cosine of the one, diba? So na siya one possible answer. Or the other answer for this one is if you're going to utilize the other answer of the integral of tangent x. So that will be x tangent x. So minus, then you have minus ln of cosine x, diba? So that's another formula. So you can also have x tangent x plus ln of cosine x plus c. So this is another possible answer. So these two are the same, diba? Because the negative sign can be, or can siya in another format, this can be represented as ln of cosine x to the power of negative 1. So that's why it leads to a positive value of ln, secant x. Alright, so questions? Okay, so I think there's no question. So let's proceed with the third example. So we have the integral of ln x and dx. So again, starting off with u and dv. So balik-balik ra itong ibuhat, no? So it's repetitive. So du and then dv. So complicated term is ln x, but we cannot integrate ln x, diba? So it's difficult for us to use that as your ln x, as your dv term. So what happens is your ln x goes here because we can easily derive that one. And your dv is, of course, dx lang, di ba? So why not? So getting the derivative of, the integral of v. So that gives us x. Derivative of du. Derivative of u is du over u, di ba? So this becomes dx all over x. Sakto, di ba? So I think this is the correct derivative of ln as far as I can remember. Okay, so if you already know the formula, so let's jump straight to the solution. So this becomes uv first, so that will be ln x times x minus the integral of v du. So x then times dx all over x. So cancel out x, cancel out x. So we have x ln x minus the integral of dx. So simple na siya, di ba? So we have x ln x minus x plus c. So you can have this answer. Or if you want to factor out x, so you can also do that one. X times ln x minus 1 plus c. So pwede po na siyang answer. Okay, so questions? Okay, so let's proceed. So this time is we have arctangent of square root of x. So again, balik-balik. So starting with u first, and then next is the dv here. So again, if you try to put the complicated term in the derivative, in the dv, so I think it's impossible for us to integrate arctangent. So it goes here. Because we can easily derive this one because we have a formula for that one. And dv is equal to dx. So also take note that we have there's no term left in the given equation. So all are replaced by a certain variable u or dv. So integrating first dv, so we have x and then du. So of course, we know the formula. That will be du all over a squared plus u squared. So du, ano siya, di ba? The, the derivative of square root of x. So that will be 1/2. Sakto ba? 1/2 and then x raised to negative 1/2. Di ba? And then you have a squared plus u squared. So a squared is 1 and then u squared is x. So you have 1/2. So maragmahog siya nga mahimo siyang. So let's try to simplify clearly para okay, so this becomes dx all over 2 times the square root of x and then 1 plus x. So that's your okay. So next is we have uv minus vdu. So uv first, so that will be, so ato lang i-arrange it so para, so x arc tangent of square root of x minus the integral of v du. So x and then times dx all over 2 square root of x 1 plus x. Okay, so we're going to have x arc tangent of x, arc tangent square root of x minus the integral of x dx all over 2 square root of x 1 plus x. Okay, so what's the next step if you're given that formula? So medyo complicated siya, no? So sa gahapon na klase mag nasayop ko og solve ani because I just use arc tangent x. So there's no square root. So I don't know if they noticed, pero mas manotice na nila nga akong igamit is arc tangent x only. Okay, so next is how do we solve your term here, kaning na square root of x. So we can solve this one by using, so again, since we have a radical expression in the denominator, square root of x, so the best possible way for the best possible method for us to eliminate this square root of x is to use algebraic substitution. So labad ng uno, so integration by parts pa, and then we have to utilize the another advanced technique which is katong inyuhang algebraic substitution. So let's try to use another color para makita ninyo. Okay, so I think I'm gonna write this one on the upper right. So let's try to isolate first the integral. So that will be x dx divided by 2 square root of x and then 1 plus x. Okay, so let z be equal to square root of x. Then getting the square is you have z squared is equal to x. And then getting the derivative is we're going to have 2z dz is equal to dx. Alright, so let's try to use a lighter shade or a darker shade lang siguro. Okay, so upon achieving those terms, so x will be z squared, dx will be 2z dz. So 2 square root of x, so that will become 2z, and then 1 plus z, z squared, I mean. Okay, so 2z can be eliminated, 2z can be eliminated. So we have z squared dz all over 1 plus z squared. So we can use long division here. So complicated kayo, no? Daghan kay labad sa uno. Yan, di ra ba magamit sa trabaho, bitaw. So, di siya magamit sa trabaho, but I think the main purpose of mathematics is for you to develop your problem solving skills and your analytical skills. So labi na ka na mga gamer dia, di ba? So gamit kayo na sa mga duwa ninyo. Mobile Legends, you know how to analyze the game, mga Valorant or unsa pa na dia. So chika aside, so let's go back to the long division. So 1 plus z squared. So 1, and then z squared plus 1, then minus minus. So you have negative 1. So the answer for this one is, so taka lang kita color, no? Makulay na kaya ang buhay. So this becomes, instead of z squared dz over 1 plus z squared, so this becomes 1 minus 1 z squared na dz. Diba? So solving it again. So let's go back to red na. So x arctangent square root of x minus the integral of 1 minus 1 over 1 plus z squared. So instead of z squared I, so this becomes, so your z squared is the x term. So this becomes x dx. So the final answer is x arctangent square root of x minus x minus ln of 1 plus x plus c. So how can I say that your 1 over 1 plus x is ln? So murag kon lang siguro years of experience na para makaingon ko na is ln, but if you want to verify it, so let u be 1 plus x, so your du is equal to dx. So this format becomes du over u, diba? Which is ln of u plus c. So taas na kayang answer, no? Marag na ko anta. Okay, so if you're going to check this one in the symbol lab, so the answer is different. So basin ako yung sayop dire. Okay, arctangent sila puro sa answer, and then the x is square root of x. Kibawa na kung ano sa ko. So just try to kuhan lang siguro. Just try to adjust the try to review this one because nakuha lang akong steps akong algebraic sub day. So we need to integrate this one fully day. So this becomes z minus the arctangent of z day. And then getting the value of z again, that will be square root of x minus the arctangent of square root of x. So mo din dapat ang answer. So sayop ta, sayop. Sayop ni. So na wrong ta dire. So ay kapala ka kay ma-wrong sana mga teacher. Okay, so let's try to adjust. So this will be x. Saan to ara? Square root of x, and then this becomes, so sige lang tagka-wrong ano. So this becomes minus, and then this becomes plus arctangent square root of x plus c. Kaya ang answer sa symbol lab is x arctangent x plus arctangent x minus square root of x plus c. So yan yung pag-arrange ang yung answer. And I think in symbol lab, it started with letting u be equal to square root of x para di siya mag-deal og kanang square root sa yung answer. So maragiyang i-convert first into the corresponding kuansa. Okay? So let's try to review this one again kay magnasayop ko diri dapita. Okay, so sakto siya but murag dire is instead of integrating the terms first, so I replace it with z before integrating. So nasayop siya. So you need to integrate first before replacing z again in the equation. Okay, so na may question. So basin maglibog mo na. Or basin nangatog na mo diya kay lamir ba ito gron kay uwan. Oh, pwede sa ni kaning naa sa symbol lab kani akong gisawat sa lower left kani. So di naman na siya ma-matter ang iyang arrangement. Pero if ganahan mo ka ng gwapa lang inyong answer na it looks nice, so you need to arrange it kung ano siguro accordingly, di ba? Or if you want to factor out arctangent, so it could also be para mas gwapa yung answer, but kung lagi ka na hassle na siya. So as long as you have the simplified version, so simplified meaning there's no more terms to group together or there's no more terms to be cancelled out, so that's fine with me as the final answer. Okay. So let's proceed to example number 5. So again, balik-balik, u and then dv. So again, your ln should always be in the derivative because we don't have any integration formula for a logarithmic. term. So this is sine x, then this becomes cosine x dx. Diba? So dapat makita ninyo ahead that you can integrate it and derive it. So in V, we can integrate this one. This becomes sine x. Your u can be derived by dx over the value of x, diba? du over u. So this becomes cosine x dx all over the value of x, which is sine x. Okay, now I suggest that you try not to convert this one into its simplified version, ang cotangent, because maybe basin pwede pa siya ma-cancel out, diba? Some of the terms may be cancelled out. So instead of letting this term be cotangent, so let it as is lang sa kay basin maka-eliminate ta og terms later. Okay, so uv, so ln sine x times sine x. So marag weird kasi tanaw, no? So let's try to use bracket. Sine x and then minus v du. So integral of sine x then times du, that will be cosine x all over sine x dx, diba? So muna siya ang purpose why we don't convert it into cotangent, because as you can see here, we can still cancel out sine x. So rearranging kay para kuan, may mo siyang nindo tanahon. So it's nice to look at. So this becomes sine x times ln of sine x minus the integral of cosine x dx. So we know that the integral of cosine is positive sine x. So this one becomes sine ln x sine x minus sine x plus c. So this is the final answer. Or again, if you want to factor out sine x, kay trip lang ninyo mag-factor out, di ba? Pwede po siya asad na answer. Minus 1. Pwede po na siya asad. So, depende rin na siya yung gusto. So, it will depend on how you want your final answer to look like. So, if you want to simplify even further by factoring similar terms, so it's okay for me. So, if kanara akong i-box yung final answer, so it's also okay. So, as long as there's no terms to be eliminated, to be simplified, or sa panadya. Alright, so questions? Okay, so I think there's no question. So let's try to proceed with the next example. Oops, okay. So this time is we have the integral of second cube x dx. So I think yesterday we weren't able to solve this one. Okay, murag nagwami kasolve ni gapon. So I don't know why, but ako pa na siyang i-review day if I'm not mistaken. If nasayop pa ko gahapon, or maybe the given equation is lacking. So I think in Symbolab, so naigibutang dito nga ang, so I think it's called as integral reduction. So, yeah, since wa pa mo ka-discuss ana, so basin maglisod mo og sabot. So, just try to search this one later. Okay, so let's go to number 7. So, to number 6 is just try to search it on your own lang sa kay. Basin sayo pa kung pagbutang sa equation or unsa. Or basin ako'y sayop. Kaya wag may answer ato gahapon sa. Okay, so let's start with u and dv. So for u, the complicated term here is unsa man ang complicated, cosine or e to the power of x. So for me, I think the best way for me to do is to let dv be cosine x dx. Because akong eu later, because magbalik-balik ra siya, di ba? My derivative for e to the power of x is still going to be e to the power of x gyapon. Diba? So du is equal to e to the power of x dx. And my v is positive sine, diba? X. So one purpose also why I chose cosine x dx as your dv, because if I place it in the u parameter, so the derivative of your cosine x will be negative sine x, and wala, trip lang ako, di lang ko ganahan na there's a negative sign in my process, di ba? Okay, I think marag mo na siya usually ang ma-mistaken sa mga tao, di ba? Kanang masayopan sa mga tao, because if you don't know how to, I mean, if you forgot how to apply the negative sign, so ma-wrong na lang yung answer, di ba? So as much as possible, avoid dealing with negative symbols. So that's why I placed my cosine x as dv here. Okay, para puro ra positive ako ang values. So if trip na sa ninyo mag-deal with negative symbols, so pwede sa inyo balihon sad. Depende ra na sa trip. Okay, so we have e to the power of x, then sine x, that's uv, minus the integral of v du. So sine x e to the power of x dx. So notice that try go against exponential gyapon function, di ba? So balik na sa ta. So let u be equal to something, and then dv be equal to something again. Di pa dahil, no? So kung para na ako, mas may siguro nga mag sin x ko diri, di ba? Okay, wala mo ko yung negative symbol. Then my dv is e to the power of x dx, so that I won't be dealing with a negative symbol. So du is equal to cosine x dx, and then my v is, of course, the integral of e to the power of x is still e to the power of x, diba? So what my answer will look like is may mo siyang e to the power of x sine x. So minus, diba? Minus, don't forget the minus sign, then bracket, because this becomes uv minus v du. So uv e to the power of x sine x minus v du. So v du e to the power of x cosine x dx. Diba? So next is may mo siyang e sine x minus e to the power of sine x, diba? And then plus, diba? Plus e cosine x dx. So notice na nibalik ta, di ba? Nibalik ta. So let's try reversing the process again kay murag nibalik ta sa ato ang original equation. So dire ba dire ako pasabot kay kani. Ako pasabot kay kani, di ba? Kani siya is the same as the given equation. Di ba? Balik-balik siya, di ba? So let's try to go back again. Okay, para okay. Mo na siyang kung usually sa inyong integral process, it's more of a trial and error method. So what if ato na sang balihon, di ba? So for us to be consistent with the declaration of the terms earlier. So let u be ex, then this one is sine na lang, ana. Sine x dx. Okay, so integral of sine is negative, no? Negative. Sakto ba? Negative cosine x. And then your du is e to the power of x dx. Now, let's try to see if kuan gapon siya. So this becomes e to the power of x minus sine x, then minus uv. That will be negative cosine x times ex dx minus integral of v du. So that will be negative cosine x. Ano na ko man uv man siya, uv. Ano siya dx. Negative cosine x e raised to x dx. So distributing the negative sign, so e to the power of x sine x plus e raised to x cosine x. So minus, so minus, that's minus the integral of e to the power of x cosine x dx. So nibalik yapon siya, no? So what's the difference between the earlier term and this term here na atong gisolve? So I think the earlier term is plus integral of ex cosine x. So just try to replay lang sa recording later. So I think it's best that we have negative VDU because in the given equation, so this one, di ba, muna siya. So in actual practice in mathematics, so usually ang nasa left side is the original equation. Diba? Nasa diya napita. E to the power of x cosine x dx. Yeah. Since you don't have the luxury of time of repeating, di ba, kanang ato siyang inana-pirme, di ba? So muna siya ang actual practice, di ba? So the left side is the equation, and then the right side is the solution, di ba? So notice that we can combine the two terms here. Ano siya? Diba? By transposing this term on the left side, so we have 2 integral of e cosine x ex cosine x dx, because if we transpose this term on the left side, it becomes positive and same na siya og dagway ani, di ba? So that becomes 2 of the integral of ex cosine x dx is equal to e to the power of x sine x plus e to the power of x cosine x. Diba? And then divide everything by 2. So the answer is the integral of e to the power of cosine e to the power of x cosine x dx is equal to e to the power of x sine x plus e to the power of x cosine x divided by 2 plus c. So, muna siya ang answer sa inyong integral. So, if maabot mo sa point na magbalik-balik na siya, so, muna na siya. So, if you go back to the original equation, so it's best that you can try to group them on the left side, di ba? Kaya muna siya ang proper way of kanang pag-solve the equation. So, writing the original equation and then equal to the solution, di ba? Now, again, since we don't have the luxury of time of repeating it again, di ba? Mumitaw nga pagsugod na to is puro na equal sign, di ba? Equal sign, then the solution. Equal sign, and the solution. So, I didn't write this portion here anymore. Okay. Dugay kita mahuman, di ba? If magsigog suwat ana. So, especially in the earlier topics nga, magsigitag suwat atong original equation. Diba? So, mana siya. Okay. So, if you want to verify that one in Symbolab, so I think the answer will be correct. So, basta nga dito nga, I think nasa Symbolab kay marag ang igamit gyapon is integration by parts nga. Basta marag iya gyapon i-group together sa iyang ka-isolate ang original equation on the left side, and the answer is still the same. Okay. So let's proceed with the next example. So if you, by the way, questions or clarifications? Oh, di lang mungutan na. Sige. So wala yung pungutan na. Okay, let's proceed here. Okay, so automatic. U and V na yun. U and dV, I mean. U and then dV. So complicated term amongst the two is the exponential. So simpler term is this one, x squared. So getting the derivative and getting the integral. So v is equal to 1/2 e raised to 2x. Then your du is equal to 2x dx. Okay, so next is we're going to have uv minus v du. So x squared times 1/2 e raised to 2x, then minus v du. So that will be 1/2 e raised to 2x times 2x dx. So eliminate 2 here on the integral equation. So this becomes 1/2 x squared e raised to 2x. Okay. Then since we don't have any constant anymore, so this becomes the integral of x e raised to 2x dx. So notice that it's still algebra against exponential function. So you need to repeat the integration by parts again. Now, so it could be that you can use 3 integration by parts process in one integral equation. Depende na sa degree of. So automatic nga muna siya, di ba? Okay, and then your du is equal to dx, and then v is still the same. That will be 1/2 e raised to 2x. So the answer again for this one will be 1/2 x squared e raised to 2x. So minus, so don't forget to put the bracket because you need to multiply the negative sign. So uv, that will be x times 1/2 e raised to 2x minus the integral of v du. So that will be V sa dong isuwat sad. So that will be 1 half e to the power of 2x dx. So this becomes 1 half x squared e raised to 2x. So minus the first term. So that will be 1 half x e raised to 2x. So minus minus, that will be plus 1 half the integral of e raised to 2x dx. So the answer will be, so I'm going to write it here. So that will be 1 half e to the, ano e naman sad? So 1 half x squared e raised to 2x minus 1 half x e raised to 2x plus, so that will be 1/4 e raised to 2x plus c. So this is the final answer. So ano 1/4 siya because again the integral of e raised to 2x will be 1 half e to the power of 2x. Yeah, times 1 half, that will be 1/4. Okay, so actually there's a shortcut for this formula, but only applicable if one term is algebraic and the other term is any function. So let's try to discover it. So again, the shortcut is only applicable if you have one term as algebraic raised to any degree. So let's say algebraic na x raised to the power of n, ana. Muna siya akong pasabot. And then any other function. Okay, so that's what you need to achieve. So how does the shortcut works? So you need to create a table. So on the left side will be your derivative. That will be your u parameter. Then your v parameter is the dv, di ba? Muna siya itong i-integrate pirme. Na u dv gyapon siya. So starting off with, so let's use another color para makita ninyo. Para makulay sa dangkuan. Okay, so my suggestion here is if you want to use the shortcut, always represent u as your algebraic term. So your x squared is here. And then your e to the power of 2x is on the dv. So as what we have done with our integration by parts, the u parameter is always the derivative, di ba? Derivative, di ba? We always get the derivative of u. And for dv, we always get the integral. So madere is starting off with x squared. So this becomes 2x, di ba? Then derivative of 2x is 2. Derivative of 0 is, derivative of 2 is 0. So we stop here. So next is on the right side. So integral of e to the power of 2x, that will be 1 half e to the power of 2x. Integral of 1 half e to the power of 2x, that will be 1/4 e to the power of 2x. Integral of 1/4 e to the power of 2x, that will be 1/8 e to the power of 2x. So we stop here because in the left side, it's already 0, di ba? So, di na taman. So, next step is for you to determine, for you to multiply diagonally in this direction. And then the operation or the symbol of operation will be alternating. So, this will be plus, this will be minus, this will be plus. So, getting the answer. So notice that the first term is already the same as the given expression. That will be 1 half x squared e raised to 2x. So in the second term, that will be minus because the operation is minus now. So 2x times 1/4. So 2 times 1/4, that will be 1/2. Then x raised to 2x. Then plus, because we have plus here. So 2 times 1/8, that will be 1/4. E raised to 2x. Then don't forget plus c. So notice that this one is the same as the answer above. So muna siya ang shortcut. So again, don't forget that it is only applicable with this condition gani siya. Because you need to reach 0 for the derivative. So pwede po siya x squared plus 1 and x cubed plus 1 basta as long as you reach 0 at the derivative column. Because you know that you can stop deriving, di ba? Okay. So isn't it amazing? Nice shortcut, but kana rasa, di ba? So dili kay siya amazing sad kay dili siya applicable sa tanang scenario. All right, so let's proceed with the final final example. So let's do this quickly kay kibaw ko gutom na mo. Gutom, tugnaw, di ba? Tanan pa. Tanan pang gibati ninyo. Okay, so if you're going to look at your equation, so either way, so both are difficult to be integrated. I mean, it's a difficult term but can be integrated. So you can integrate sine 3x, but you'll be having a negative cosine, di ba? So let's try to put this one here, sine 3x, because I don't want to deal with a negative symbol. So my dv is e raised to 2x dx. Alright, so this becomes v is equal to 1/2 e raised to 2x. And then my du here is 3 cosine 3x dx. So why there's 3? Because we have an angle 3 here, di ba? That will be cosine u du, di ba? As per formula. So again, as per formula, derivative, this will be cosine u du, di ba? That's the derivative. Okay, so we still have to get the derivative of u inside the angle. Alright, so next is, my next mga una. Okay, so shortcutting the format na ato lang siya i-arrange immediately. So sine 3x then minus v du. So that will be 1/2 e to the power of 2x times 3 cosine 3x dx. So notice again that it's still the same. We still need to utilize the integration by parts. So let's try to factor out a constant, that's 3/2. So e raised to 2x cosine 3x dx. So again, we apply the integration by parts again. So of course, let's try to use the same designation. So my dv is still e to the power of 2x dx. Okay, para pare-pareha lang siya sa above na So du is negative 3 sine 3x. So naka-negative ta no. So magdi siya malikayan dyan nga maka-negative ta. But at least ini pagkasugod wata nag-negative dayon. So again, depende rin dyan sa inyong trip if you want to deal with negative symbols. So wata mo gibawalan nga mag-negative. Okay, so 1/2 e to the power of 2x sine 3x minus 3 halves and then uv minus v du. So that will be 1/2 e to the power of 2x cosine 3x minus the integral of v du. That will be 1/2 e raised to 2x times negative 3 sine 3x dx. So bracket. So this gives us 1/2 e raised to 2x sine 3x. So 1/3, 3 halves times 1/2, that will be negative 3/4 e raised to 2x cosine 3x. Then minus, then 3 halves times 1/2 times 3. So 3 halves times 1/2 times 3. So that will be negative 9/4. The integral of e raised to the power of 2x sine 3x dx. So notice that this term here can repeat siya sa given equation above. So it so happened that the term, so dapat negative ni siya nga term, di ba? Negative term para ini-transpose sa left side, it becomes positive. Di siya ma zero out, di ba? So if we try to combine this one on the left side, this looks like e to the power of 2x sine 3x plus 9/4 integral of e to the power of 2x sine 3x is equivalent to the remaining term on the right side. That will be 1/2 e raised to 2x sine 3x minus 3/4 e to the power of 2x cosine 3x. So muna siya ang dagway. So 1 plus 9/4, that will be 13/4, di ba? So this becomes 13/4. The integral of e raised to 2x sine 3x dx equivalent to 1/2 e to the power of 2x sine 3x minus 3/4 e to the power of 2x cosine 3x. So for us to eliminate 13/4, so we need to multiply everything with 4/13. So the final answer, so ako lang ibutang dire sa babaw is e to the power of 2x. Ako lang igamaya kay murag wala na space. Sine 3x dx. So 4/13 times 1/2, that will be 2/13 e raised to the power of 2x sine 3x, and then minus, so times negative 3/4, so that will be 3/13 e raised to the power of 2x cosine 3x plus c. So this is the final answer. So kani siya is the same as example number 7, but katuwa lang siya is dali lang siya kay you added one whole numbers, di ba? So kani siya is pag transpose sa katong original equation on the left side, So since there's the coefficient of 9 over 4, so 9 over 4 plus 1, that gives us 13 over 4. So in problem number 7, that's 1 plus 1. So you have 2, the integral of the equation. Okay, so questions or clarifications? So for sure you don't have any questions because gutom na, di ba? And as for the concern regarding the departmental exams, I'll try to raise your concern as well. Alright, so just try to prepare for Monday because muna di ko kabuot if it will be transferred to a later date or not. Basta just try to prepare for the exam. Okay, so if you don't have any more questions, so thank you very much for listening and see you all on Tuesday.